In this tutorial, I'm looking at Leaving Cert Higher Level 2023, Paper 1, Question 2. The first question, we're given the quadratic x squared plus bx plus c. And we're told the minimum point on the curve, and we're asked to find the value of b and the value of c. If you want to practice similar questions to this, go to our course and look at Differentiation 15, which talks all about turning points, maximum points and minimum points. In this question, we're told that this curve has a minimum point at 3 minus 1. We have to use that information to find b and to find c. So obviously, since we know what the turning point is, what we should do is take this curve and try to find the turning point. In order to find a turning point, the first thing you do is you get the first derivative. The derivative of this quadratic is 2x plus b. In order to find a turning point, you let the first derivative equal to 0. So I know if I let 2x plus b equal to 0, then the x value has to be equal to 3. The question says that there's a turning point at the point 3 minus 1. And I know that to identify turning points, you get the first derivative, you let it equal to 0. So it must be the case now that when the first derivative equals 0, the x value is equal to 3. So I can just sub that in. I can say that 2 times 3 plus b is equal to 0. And this is enough information now that I can easily find b. All I have to do is simplify this a little bit, bring the 6 to the other side, and my value for b is equal to minus 6. And when I have that now, it's going to be very simple to work out c. I now know that the quadratic is x squared minus 6x plus c. What I'd start thinking now is, instead of viewing this as f of x, I'd start thinking of this as my y. I know that y equals x squared minus 6x plus c. And I know that the point 3 minus 1 is on the curve. If this point is on the curve, I can just sub it in. Instead of an x, I can sub in a 3, and at the same time, instead of a y, I can sub in a minus 1. If I do that, I'm going to find a value for c. So I went ahead and did that. Instead of a y, I put in a minus 1. Instead of an x, I sub in a 3. From there, it's very straightforward. We've only got one unknown, so you simplify it down, and you end up with c is equal to 8. I think it's good practice then. I'd always write the quadratic at the end. You know, I've identified what b is, and I've identified what c is, so that means the quadratic itself is x squared minus 6x plus 8. Okay, in part B of this question, we're asked about limits. And we've studied this in the tutorial Functions 10. We've also studied it in sequences and series, so if you want to look at similar questions to this, you can either go to the sequences and series section or at the end of the function section. There's questions similar to this that you can practice. The stuff we've covered that relates to this is essentially that there are a number of rules you can apply to limits. And in this case, if I have the limit as n approaches infinity of this fraction plus another fraction plus another fraction, I can just split it into 3. And that's the easiest way to deal with this question. I've split this up. I want the limit as n approaches infinity of the first fraction, then the same thing of the second fraction, then the same thing of the third fraction. It just makes our life a little bit easier. But from here, things get a bit trickier, so I want to go through it. First of all, like 1/3 squared is 1/9. If you get 1/3 to the power of 3, that's 1 over 27. Then it becomes 1 over 81, and it gets smaller and smaller and smaller and smaller. So if I get 1/3 to the power of an infinitely large number, it's essentially 0. It's so small that it might as well be a 0. So the limit of this function is 0. If you get 1/3 to the power of 1,000,000, it's a really, really, really small number to the point where we can actually treat it as 0. So the last part, we're just going to ignore it. That's a 0, nothing to do with it. We have to deal with these two in a different manner. Remember what we've studied. If I'm getting the limit as n approaches infinity, I have to divide each term by the highest power of n. The highest power of n in this fraction is n to the power of 1. In other words, there's no n squared, so it's just n to the power of 1. So all we have to do to deal with the first bit is we're going to divide each thing by n. So the top of the fraction becomes n over n, and the bottom of the fraction becomes n over n plus 1 over n. In other words, I've taken each term in that fraction and I've divided them all by n. And we do exactly the same thing with the second fraction, and it's going to look very similar. N plus 1,000 over n will become n over n plus 1,000 over n, all divided by n over n. Now we can simplify this down. Obviously the first fraction there, n over n, is simply 1. So I get 1 over 1 plus, and 1 over n, there's nothing I can do with it, so I'll just leave it as it is. And for the second fraction, again, I have to keep my limit because I haven't applied it yet. N over n is 1. 1,000 over n is simply 1,000 over n. And the bottom of the fraction, n over n, is 1. Now, we need to think what would happen if I actually subbed in infinity here. Well, remember, any number divided by infinity is simply 0. So 1 over infinity is 0. Same, 1,000 over infinity is also a 0. So basically the 1 over n, if I subbed in n was equal to infinity, 1 over n just becomes a 0, and 1,000 over n just becomes a 0. So this fraction just becomes 1 over 1 plus 0. 1 over 1 plus 0 is just 1. This fraction becomes 1 plus 0 over 1. And obviously 1 plus 0 over 1, that's just 1 over 1 as well, so that's just a 1 too. So the first fraction just ends up as a 1, the second thing just ends up as a 1, and the third bit is a 0. So my answer is simply 1 plus 1, which is 2. In part C here, we're given a function g of x. And g of x is kind of composed of two different parts. First of all, it's a straight line going from the point minus 2, 4 to the point minus 1, 1. And then it's what's referred to as an asymptote. Now, you very well might never have heard that word before, and that's fine. But basically, an asymptote is a curve that is approaching a certain limit, but it will never get there. And basically, this is an example of a line that is getting closer and closer and closer to a y value of 3, but it'll never get there. So essentially, this line almost becomes a horizontal line. It almost looks like a horizontal line. And arguably there, it's never actually going to hit 3, even though it looks on the graph like it's reached 3. In theory, it's like 2.99999. It's really, really close to 3, but it's not quite there. But essentially, like I'd view it like it looks like it's meeting the point 2, 3. That's the way you can think of it. And the first thing we're asked to do in part I is to draw the graph of g of x minus 2. Well, if you take a function and you just subtract 2 from it, you should remember from our study of functions, if you just take away 2 from a function, everything just drops down 2 units. So if this is the point minus 2, 4, well then for g of x minus 2, it's simply going to go down to the point minus 2, 2. So it goes from a y value of 4 to a y value of 2. This is the point minus 1, 1, so it's simply going to drop down to the point minus 1, minus 1. The y value drops from 1 to minus 1. And now the curve, instead of approaching the point, instead of approaching a y value of 3, it's going to be approaching a y value of 1. So to do the line, that's the easy bit. I'll just join up these 2 points, and this, it's basically identical to the line above, just 2 units below. And now, like in my mind, what I'm doing is I'm trying to draw a line that's going to get really, really close to 1 there. So this is what my asymptote would look like. You're basically just trying to replicate the exact same shape as the bit above it. So that's your, and again, it's important in an exam that you label that. So I label that as g of x minus 2. And in the final part of this question, it's actually a little bit slightly more difficult. We're asked to graph g of x plus 3. So we've just seen one where the minus 2 was not in the brackets. If I have g of x and then I subtract 2, that just brings it down. And if I had g of x plus 2, that brings it up. So the numbers outside of the brackets after a function move it vertically up or down, whereas the numbers in the bracket move it horizontally left or right. And it's the opposite of what you would guess. So a g of x plus 3, a plus 3 will move it down 3 units to the left. So everything is going to move down 3 units. Again, we studied that at the very start of functions. So if you're rusty on that, go back to the first few tutorials we did on functions. So this time I'm taking the point minus 2, 4, and I'm moving the x value. So instead of having an x value of minus 2, I have to go down 3. It's now going to have an x value of minus 5. So this point goes left 3 units to minus 5, 4. The point minus 1, 1 goes down from x equals minus 1 to x equals minus 4, and that's the start. You know, that's my straight line. And now the asymptote, the part of the curve we can see, it's approaching, like it's going to the point 2, 3. So if I move the x value across 3 units, 2 minus 3 brings me to minus 1. So now instead of going towards 2, 3, I'm kind of going to be going towards minus 1, 3. So try and, again, you're just trying to imitate the shape, try and imitate it. You're not going to be expected to be 100% because when it's a curve, you can't use a ruler or you can't use anything like that. So it is freehand, but insofar as possible, just try and replicate that shape. And that is what g of x plus 3 would look like.